It's a high-tech conversation.
And a low-tech topic.
Live on the World Wide Web via Zoom. Bench Talk 101.
Right, well, this evening, folks, I'm giving Shrenick a little bit of a break, although I think actually he's probably going to be concentrating far more on seeing whether I fall into trouble and he needs to take over. Anyway, this evening we have a talk from a gentleman I met at a woodworking show several years ago now, and he must be the most enthusiastic guy to talk about wood that I've ever met. And it's a real pleasure to know him and to have him come along this evening and talk to you tonight. Well, I'll hand over to Gervais Sawyer.
Thanks for inviting me. You can't imagine how stressful this is speaking to you, because I know that you're all people who polish off a few secret dovetails before breakfast, and you probably regard my biscuit jointer as the work of the devil. But anyway, how did I get into wood? Well, my father was a civil engineer, and I didn't feel you had to be good at maths for that, and I was okay, but not really good at maths. And my mother was a dairy farmer, and so no more 6 a.m. milking for me. That's the end of that. So I just happened to see a brochure on the careers shelf from the Timber Trade Federation about careers in the wood trade, and that looked interesting. So I managed to get a job as a trainee with a company called William Mallinson's, who were the hardwood people, who were very diversified in their activities. And that was the deal, you know, start in the yard at 7:30, learning the business from the ground up, and the day ended at 5:30. A quick snack, and then off to evening classes at London Polytechnic from 7 till 9:30, 3 nights a week. I really just don't know how I managed to do that, because it's how I found the energy. Anyway, after 3 years and a lot of experience in hardwoods, veneers, these are all Mallinson companies, hardwoods, veneers, manufacturing, and with an Institute of Wood Science qualification, I felt that the time had come to learn a bit more about wood, especially the softwood industry. And so I got a job with a famous company called Burke, Bolton and Hayward, who were founded in 1830. The story of Burke, Bolton and Hayward is worth telling if you bear with me. The early steam engines wouldn't burn coal, they burnt coke. So in producing coke, you produced a lot of gas, and that was good for lighting Coronation Street. And you were left with a lot of tar. And of course, what do you do with that? Well, you chuck it in the River Thames. So along came Henry Potter Burt, and he said, where there's muck, there's money. And he found by distilling tar, you could get all sorts of other chemicals out of it, including creosote, which was a very good wood preservative. He then got together with Bolton, and they started creosoting timbers for the railways, to the extent that as the railways spread across Europe, there were more than 350 creosoting plants. So they then started to import the timber and offer a treated product. And so the timber business grew up one way, and chemicals grew up the other way, including an amazing array of things, right from aspirins to dye stuffs and the like. Anyway, their depot that I got a job with was in Belvedere in Kent, big site, 65 acres. And the job seemed to change every couple of years. They moved me around. So I got a lot of experience in kiln drying, saw doctoring, you know, particularly bandsaws and large circular saws, and pivotally, wood preservation. Well, nowadays we call it wood protection, because that means we can encompass more things. And we manufactured telegraph poles and transmission poles and all the track work for London Transport Underground Railway. So if you travel on London Underground, you can rest assured they still have the highest quality control standards imaginable. So after 10 years, I rose to work manager there. And in that time, I got involved with an organization called Young Enterprise, which is trying to get young people involved in business. And I also taught wood technology at evening classes. So I felt like another challenge and moved back into hardwoods. This is heavy hardwood sawmilling. And the depot there had was a big kiln drying operation with 30,000 cubic feet of kilning capacity, and we burnt 1,500 gallons of fuel oil a day. Yeah, this is that's all I'll say about it, because that career move was really bad, and I just want to forget all about it. It's erased from memory banks, but suffice to say, it had appalling industrial relations problems. So bad indeed that it was life-threatening. I mean, the situation would be that if a foreman didn't falsify piecework records, then the labour force would beat up his wife. And it was routine that you checked your brake lines before you set off home. That bad. Anyway, so my wife was working at the time, we hadn't got a family, and she said, walk away from it. So I walked away from it, and as luck would have it, an opportunity arose to teach wood science at what is now Buckinghamshire New University. That's in High Wycombe. And there specifically I taught wood trading and trained saw doctors from all over the world. But I discovered my passion for wood preservation, which we now call wood protection. And again, the job changed every few years, and it finally developed into advanced research and consultancy, which is great, you know, a new problem to solve every day. Well, I was at Bucks for 32 very happy years, worked with some of the most wonderful colleagues imaginable. We had a principle that we'd learn something new from each other every day. So we each had our own discipline. So a head would pop up over the partition and say, hey, Gervais, imagine I don't know anything about this. Please explain this to us. So, or else we'd share something we'd seen in a magazine or a journal. But all good things come to an end. So a new director came into the university, and she wanted to close all courses that required expensive workshops and laboratories. So that was that. Science was one of the first to go. But I hung on there because the severance pay was pretty good. And I was past retirement age anyway, theoretically. You know, teachers can retire a bit early, 60. But after a week of retirement, the phone started ringing, and I've been working the last 14 years, more hours a week than ever before. And I'm sure you agree, if you enjoy what you do, why stop? It's great. So what do I do? And I'll call on Mitch to introduce the first slide.
I've just mentioned at this point that we went through a technical run through earlier on, and there was a slight bug. So bear with us if you're watching live. If you're on YouTube, then you won't get to see that blooper.
Righto. Slide number 1, please. I'm sure you want to see my workspace, because I do a very diverse range of things. And so some of you may be pitying. Next slide, please. A little bit more detail. The lathe, which is used all the time for making components and spare parts. And moving along a little bit more. Oh, well, underneath the lathe, try to be tidy. All the power tools. Next. Have any of you got one of these? Because it's the best tool I ever bought, and with little improvements, it's better than ever. You may see, if you know one of these, the front cover attaches by sort of spring clips, but if you make that bolted on tightly, put bolts right through it, the whole head becomes absolutely rigid, and the blade will never come off, and it'll saw so accurately. I love that machine. Next slide. Have to tell you about this. My younger daughter, she was 16 at school and working weekends at IKEA. And she said to me, Tata, your tools are an absolute mess. I'm going to design you the ultimate tool cabinet. So being in IKEA, she created a cabinet, which is a flat pack. So first of all, you buy the carcass as a flat pack. It's all pre-drilled. And then you buy drawers, which are in units of 1, 2, or 3 depth. And then you buy drawer dividers, which are in groups. And they were all flat packed and barcoded. And it's wonderful, absolutely wonderful. Unfortunately, the girls' school didn't really get it. So they awarded first prize to somebody who made a teddy bear. So I'm very sad about that. Next slide, please. Circular saw. Yeah, you know, I so rarely use a circular saw. Every time I use it, I think, bloody hell, it's so dangerous. Bandsaw gets, the big bandsaw on the other side gets used most of all. Next, please. Any of you know Wood Gears in Canada? Matthias there. Well, this is one of his designs for Linisher on the left-hand side, which is a really excellent machine for fine finishing, and the belt sander. Next slide. I also do quite a lot of electrics and electronics, so that's my repair facilities there. And next. How many G cramps does a person need? The answer, just one more. I'm sure you agree. Next slide. Oh yes, planer thicknesser, vacuum cleaners everywhere, dust extraction. And behind it, you can see my wonderful Ryobi chisel mortiser. They don't make it anymore, but it's such a lovely machine. You can actually just clamp it onto a door that's been hung and take out the mortise lock. And the drive for the chisel has a gearbox, so you can drive a 2-inch chisel if you want. Wonderful. Next. All right. And there's more and more. Welder, so on and so on. Next. And I have personal projects which I've introduced here. My instrument of choice is a Hammond Dulcimer. This is one I made a few years ago. Don't know if you know the instrument, but it's got 88 strings, so you can spend your whole life tuning it. And I thought that's a mug's game. So inside, I braced it with Invar steel, which is a very low expansion alloy steel. And it sort of works. It stays in tune for 3 or 4 months at a time. Just need the odd string tweaking up. Next. This is a sad story. A friend of mine moved house to Hither Green, and it was a bit of a wreck of a house, and the garden was a jungle. And he was digging over the garden. He rang me up and said, "Gervais, I think I've discovered a musical instrument buried in the garden." So I went along there like Time Team and carefully excavated, and it was a very early vibraphone. None of the frame was there. It had all rotted away. There was just a trace of it in the soil. And the paddles on the vibraphone, they were driven by a clockwork motor from a wind-up gramophone. So after a few months of diligent work, cleaning it all up and replacing one of the bars, made a new frame, came to fit the bars, and I had one of these dreadful measure twice, cut once episodes. So I hung it up in the workshop, and it stayed there for 2 years, and well, I've yet to finish it off. It's great fun. Okay, next. Right, so I'm in business as a wood consultant, solving people's problems. Very often I don't know the answer, and I just direct them on to somebody who does know better. Anyway, so I introduced myself as the Saw Doctor, and I have a YouTube channel. You have to search for the Saw Doctor Wood Technology, otherwise you'll get 200 videos by an Irish pop group. And they're short videos on wood technology that I've created for school children. They've got just a bit of fun. And if you've got more ideas, please let me know. I want to create some more. So first thing I do is wood identifications. Well, why? Very largely, they're for building restoration projects or repairs, and the policy is to replace like with like, so that you know the strength properties are similar. Or if it's if the conservation officer's crazy, then they say, yes, you've got to put back hazel twigs behind the wattle and daub walls. I mean, it's crazy. Secondly, these days, if you're buying timber, the rules, the legislation for buying timber says that you must exercise due diligence, that what you purchased is legal and is what they say it is. So sometimes that's easy, sometimes it's very difficult. I know my limitations. And if it is beyond me, then I'll direct them on to Peter Gasson at Kew Gardens, who is probably the best around. And possibly I have to identify wood as part of other investigations in wood protection. And lastly, if somebody's just curious, well, if you just are curious, there's no charge. All the rest of them, they pay me the proper rate. Okay, next. And here's my little identification lab. The workshop is beyond there. It's all en suite in the house, so you can be really envious there. You know, I just say, wife, tea, please, and it arrives. Yeah, I like hospital food. I can say things like that. Next, please. So generally, in identifying softwoods, you have to cut thin sections for microscopic examination. So this is a microtome, sledge microtome, and generally I'm cutting sections that are 30 micrometers thick. But if necessary, I can go down to about 5 micrometers thick. Yeah, and next, and 2 microscopes, maximum magnification about 1,000, but 400 is usually sufficient. And the one on the right is set up for polarized microscopy, which is very good for detecting early signs of decay in wood. Okay, next. And of course, I have to have my reference keys for actually identifying things. So what you see here is it's a radial view of pitch pine, and that's what it looked like. The horizontal line are the ray cells, and the vertical lines are the trachees. Next, there's a close-up. Although I've got solid blades, I try to avoid using them, mainly because they're so darn expensive. Solid blades, £250 a go, and £50 to have them reground. It lasts quite a few years, but these are disposable blades, and they're about £1 each. And you just slide them along and use a new piece. So the pack of 50 will last me 5 years, I suppose. Next. This job was for a network rail viaduct, 280 samples, creosoted, a lot of them, and they were either Douglas fir or pitch pine, and the occasional googly thrown in. It was only the thought of the money that kept me going. It was 10 days of hard work and a lot of solvents. If it's creosoted, you section it in toluene to dissolve out the creosote, and it's a bit fumy. Next. Right, I do wood identifications for people. Again, if they're wood borers, that's no problem to me. If it's something unusual, then I'll go up to the team at Natural History Museum. But people want to know what's rotting my house, eating my furniture. And some of them quite interesting, like had a court case earlier this year. Somebody bought some beach furniture 10 years ago, and all of a sudden, very large beetles started to emerge. Well, this is a phenomenon that's known called delayed emergence. And this woman was determined to take it to court. And the lawyers had taken over £10,000 off her in legal fees for a piece of furniture that cost £400. Just hate lawyers. Right. Next slide, please. Do you watch Grand Designs? Because the winner last year was some houses in Eton made of expanded cork. Now, the Spanish and Portuguese, because of the loss of cork bung markets, they're very anxious to find new markets for cork. So the trees keep growing. The trees produce acorns, which the pig farmers are very happy about. So anyway, they make this cork rather like puff wheat, and then it's molded into blocks with drainage channels. This ticks every box, doesn't it? It's high insulation performance, environmentally friendly, blah, blah, blah. Right, what Grand Designs didn't tell you was that these were being eaten. Now, if you've ever seen woodworm in your house, you've seen a little pile of boar dust builds up over a period of months. Well, this was producing a shovelful of boar dust every day. So a little bit of searching around, we found the culprit, which you'll see in the next picture. Oh, yeah, right. This little creature. This is very, very small, Lacius Bruneus, the red wood ant. And normally the redwood ant is minding its own business, nibbling away at the rotted internals of an oak tree or similar. It just so happened that this expanded cork provided the perfect refuge for laying its eggs, and creating a little nursery. It wasn't eating the cork, it was just tunneling out a refuge. So yeah, I don't know what they've done about that. Treated it with permethrin or something, I think. Next picture, please. Quite often have to say whether a piece of wood has been treated with wood preservatives, and quite often it is, if any, or else the quality of wood preservation. So let's look at the next one. This is a piece of stud work purchased from Wicks. If you know me well, you know I've always got it in for Wicks. Sorry, Wicks. Yeah. Anyway, Wicks's website will use, well, every wood merchant will use the same sort of emotive words. Treated under high pressure for deep penetration. Ha! Well, I've treated this with a reagent which dyes the copper, which is the main constituent of wood preservatives, and my magenta color. Can you see how far it's gone in? A millimeter, even less on the top surface. So it's not pressure impregnated. I think pressure painted is probably a better word. Yeah, but that's quite normal. So yeah, the quality of it's not really the fault of the treater, it's the fact that spruce is exceedingly difficult to treat. It's just the way it is. Next picture. Okay, I also produce a lot of research materials for laboratories or anybody else. For instance, if you are a wood preservative manufacturer and you are doing quality control on your products, you want to know how effective they are. And the way to do it is to impregnate little blocks of Scots pine sapwood. The sapwood of Scots pine is rated as the most decayable timber there is in the world. So that means selecting out Scots pine sapwood and then cutting these blocks, thousands of them. Also produce feeder materials for people who are researching marine borers. Now, this is a rather strange one because there are no actual wood preservatives approved for use in the sea. So why bother to do this one? Well, it's an interesting story. A colleague of mine, Simon Cragg, Prof. Simon Cragg down at Portsmouth Marine Lab, one of his students was studying the most destructive wood borer, which is called gribble. It's like a very small woodlouse. But what it lacks in size, it makes up in numbers. So if you see a wood pile at the seaside which has a waste in it like that, that's gribble at work. Well, one of his students identified the gene in this animal which expresses an enzyme which turns wood directly into sugar with no methane release. So everybody's suddenly very, very excited. Here we are, this is third generation biofuels. No methane loss, just any old wood, and out comes sugar at the other end, which you can then turn into ethanol, whatever. And some of these samples I produce are very small, thousands of 1 millimeter by 1 millimeter by 40 millimeter long pieces. And they all have to be oriented, so radial and tangential faces face a certain way. It's amazing, I've still got my fingers left. And I produce special laboratory equipment, and this is probably what you would love to do. Imagine somebody came to you and said, I want you to build me this. I said, how much is it going to, how much are you prepared to pay? They said, oh, blank check, just get on with it. So here we are. Next slide, please. Oh, here we are. This is a piece of Scots pine, and I've treated it with a reagent which stains the heartwood bright red. So I don't want to see any of that in these feeder blocks. It's all got to be the pale sapwood. Next. These are those of the blocks. They've been treated with who knows what preservative at who knows what concentration, and they're placed, they've been weighed, and then they're placed in a jar here on a culture of a particular fungus. And this fungus is celerot, Coniophora puteana, And after a period, you take them out and see if there's any weight loss. That's a measure of how effective your preservative is. So I can't imagine working in the laboratory doing that for thousands and thousands of these samples. It must be quite tedious. Next. Oh, here we are. This. Oh, excuse me a minute. The other marine borer is teredo, shipworm, which is a mollusk, rather like a mussel or oyster. But the shells have been adapted to being tunneling cutters. So it's a soft-bodied animal. It's actually a plankton feeder, sucks seawater in, filters out the plankton and blows it out again. And at the other end are these two shells which are tunneling backwards and forwards, boring a hole, and the animal's getting bigger and bigger all the time. So it's a one-way suicide trip. Well, this animal produces very interesting enzymes, which have shown promise. Well, they're already used, the enzymes are already used in enzyme washing powders, and they'll tolerate very high temperatures. That's a clever trick. But now they're showing promise in breaking down PET plastic directly back into its original component chemicals. Problem is, if you want to study the animal, how do you get it out of the wood without killing it? Because it's like a soft-bodied worm. So originally, we used to have packs of veneers clamped between two sheets of plastic, and you could x-ray them from time to time, see how the animals are growing. And then when you're ready, you can peel off one veneer at a time and get your animal out without killing it. But we've improved that a little bit with this square rainwater downpipe packed with these little splines. And again, you can remove the splines and release the animal without killing it. Next, please. Right. I love this. Was one of my favorite jobs. They wanted a pressure impregnation plant for research on impregnating wood with phenolic resins. So it can apply vacuums at different levels and apply pressures up to 20 bar pressure. Yeah, nice job that was. Next one. And this is a very recent one because everyone's very interested in the problem of plastics in the sea. And the news media will show you a beach with plastic bags and old flip-flops on it and everything, because the majority of plastics in the sea are microscopic little particles drifting around. So how can you separate those from seawater? So the technique here is you load your seawater into the column, and then you add a salt solution which has a higher density. Well, the higher density settles to the bottom, and the plastic particles, being lighter, float up to the top. Shut the valve off and you've captured your plastic particles, and then you can analyze those. Fun, that, isn't it? I love things like that. Great, thank you. Next picture. Next thing I do is I edit International Wood Products Journal. So if you had a camera behind me, you see I'm surrounded by monitors so that I can do the editing and such like. It's a peer-reviewed journal. Was formerly, once it was called the Institute of Wood Science Journal, published by Taylor and Francis, and we've got contributions from 30 countries to date. So wood science is truly a global club. It gives me daily contact, thank goodness for Skype and Zoom and everything, with some 300 wood scientists around the world. And the journal publishers also pay for my travel to exotic places, you know, in COVID-free times. I don't do tropics and I don't do long haul. So the places I like going are Scandinavia and Eastern Europe, particularly, because hospitality in Eastern Europe, balanced life is just lovely. So I'll try to learn something new out of all this every day. Next slide, please. So here's the International Wood Products Journal. I don't suggest you go out and buy it unless you're having trouble sleeping, but this is pretty heavy stuff, okay? But I try to arrange it so that it sparks off some natural curiosity. You just, you know, the odd article you might say, oh, that's interesting, I'll get to grips with that. So yeah, okay. This is a big part of my work. doing site investigations. What went wrong? What to do about it? Big presentation coming up shortly. And it's suffice to say, there are many architectural blunders. How are they? So often you arrive at site and you say, architects, you can't do that. And the knowledge isn't secret, it is freely available. Then there are many site blunders, and by the time you discover it, the subcontractors over the hills and far away. But it's probably fair to say that a majority of problems are moisture content related in one way or another. To the extent that I buy up, whenever they're available from Lidl, moisture meters that cost 10 quid. They're all remarkably accurate. And I give one away and say, look, next delivery of timber, check the moisture content. If it's over 20%, send it back. You'll only have to do it once, and then there will be a big sign in the transport office say, lots of blogs, picky customer, make sure it's dry and sheeted up. Next. I've been doing this for nearly getting on to 30 years, outreach to schools, career opportunities in wood. It is, after all, the wood industries is the 5th biggest economic activity in Britain. It's about the same as iron and steel, which is quite an extraordinary thought. And yet, to school teachers and school children, it's completely invisible. They just don't know it. And if you press them, or the occasional teacher thinks, oh, that's carpentry, is it? That's it. About that much is carpentry. Somebody's got to grow it, mill it, ship it, process it, and all the rest, you know. Anyway, so in order to do that, I go to schools, careers fairs, wood fairs, and the like, and it's great fun. So here's one I do. You've got to have a gimmick, or more, or several, to stop them drifting around. So here we are. I have a little framework there with a little pallet suspended from a little wishbone there of pine, and the cross section is just 3 millimeters by 3 millimeters. And I invite them to stack concrete paving blocks on the pallet and guess when it'll break. And sometimes I get them to bet with chocolate money when it'll break, and of course it won't break. They get something like 85 kilos on there and it's still fine. You can pluck it and pluck the wishbone, and it pings, it's so tightly stretched. And when it fails, it's not the wood that breaks, it pulls out of the gripping tongs at the top and bottom. So you'd be convinced that there's tensile strength of wood is phenomenal. Next one. After doing that, they're pretty convinced that wood is strong in tensile. So I get them to build a bridge. Right, it's only 2 meters long, but 3 meters if necessary. And it's a triangular box beam which fits together with slots and tabs, rather like origami. And it's a suspension bridge, but the suspension chain is underneath it rather than on top. That's fine. And those suspension chains are made of maple, very straight grain maple. And I've tested each chain to 250 kilos. So they all stand on that. We've got 10 children on there before now. And it creaks and groans a bit. That's all right. The stresses are distributing themselves. And then they get off and pick it up, and it weighs just 3 kilos. That's how to use wood efficiently, you know. That's good fun. Next slide, please. And I also work for the Wood Technology Society, which used to be the Institute of Wood Science. It's part of the Institute of Materials, Minerals and Mining, but we all just call it IOM3. And it's the professional body for people who work with wood. And lastly, I offer training courses for the property care industry. Those are the people who are treating your rising damp and dry rot and the like. Lovely people. It's an industry, they're all quite small companies. But what impresses me is they're pursuing further knowledge just for the pleasure of it, even though it's not an immediate financial advantage to them. That's a wonderful thing. And they put themselves through, well, I was doing Viva Voce exams for them last week. You imagine you've done 9 hours of write-a-thons on various days, and then you sit down for a half-hour one-on-one viva voce exam. That's pretty stressful, especially if you haven't sat an exam for 25 years, as a lot of them are. Whoa, yes. Okay, next slide, please. So these are the site investigations. I picked out a few from the case book, as it were, to illustrate my point. And I put in this order: if Wood's failed, is it because the design was faulty? Is it the execution of how it was put together? Or was the material faulty? It could be anyone or all of those. You choose. Okay. First picture, please. Well, in wood circles, architects are regarded as a soft target. You know, it's open season for shooting, sniping at architects. But let's be fair. Next picture. Architects can do some wonderful things in wood. Look at this lovely glulam roof and cladding here. That's great. Incidentally, any of you watching the Best British Woodworker on Channel 4? It's on tonight, isn't it? Episode tonight. Anyway, one of the judges is Alex de Rijk, who is a very accomplished man, very nice, but he's not really being allowed to show his personality on that program. We'll see. Next picture. This is modern construction. It's entirely timber. It's called CLT, or mass timber, cross-laminated timber. The walls may be up to 450 mil thick solid wood, and all prefabricated in a factory with services, windows, doors and everything. And the sections arrive on site and you just screw and bolt them together. So there's a little team of men there with cordless screwdrivers and the like. The best known one is in Hackney in London. It was the first one in London, which is 9 stories high, the Stadthaus, and it went up 1 story every 3 days. Yeah, dry construction, people can move in straight away. I said to the architects, gosh, your clients are really eco-minded, aren't they? This type of construction. They said no, all they were interested in was they could get the rent coming in sooner, because it went up in a space of 3 months as opposed to 2 years if it was steel and concrete. Next picture, please. So, is it the design? Next. Right, now this one, so this is not the right way to do it. I'm giving you the best first. This is a circular church, new church in Sussex, and all the pews form a semicircle around the church, all in American black walnut. So there's something like £100,000 worth of black walnut here. But the architects were a very well-known design studio, who I won't name, but they designed a lot of the Olympic Stadium in London. And they designed it in such a way that these staves are glued together and they're separated by a piece of 1 millimeter thick white ash veneer. That's a bit suspect to start with, but to make it even more difficult, the white ash veneers are always facing east-west. So as you enter the church at the back, all those ash joints are at right angles. It's a nice butt joint. But as you work your way around, the joints become more and more oblique. Well, it's an amazing piece of CNC programming and machining done by a company called Swift Horseman, who I can mention because they got out of business as a result of all this. Next picture. There you are. So looking at that, you might think to yourself, first of all, I've glued all the staves together, then I've machined the faces, then I've glued it up with the ash veneer in the middle. And you think, how are you going to actually clamp that together so the glue bonds? And the answer is they didn't. Next picture. Okay, now look closely at this. Can you see the grey gaffer tape along the backs? That's every joint that's failed. Hundreds and hundreds of them. So with a bit more investigation, next slide. No glue contact at all. And in any event, the process of peeling or slicing an ash veneer damages it mechanically anyway, so it would have failed one way or another. So Swift Horsemen saw trouble coming and they went into administration and disappeared. So I don't know what the final result is, but the judge in the court will probably say, well, it's 50% the designer's fault for designing something that you can't build, and it's 50% the wood machining specialist's fault for not saying you can't do this. So the whole lot was scrap. There were other horrible things in the building, but tragic. All that black walnut. I was sort of wondering, being as fragile as that, how did they get it off a lorry and into the building? So I have a technique for this. You go out and make a cup of tea outside, as if you were going to have a smoke, which I don't, and have a chat to the gardening team, the gardener. And chat to the gardener, and he said, how did they get these off a lorry without breaking them? He said, well, they all broke many times over. He said, take up a seat base and you'll see it's held together with hundreds of those butterfly clamps for joining kitchen worktops together. So there you are. Next picture, please. Has a lovely Victorian house in Rayleigh-on-Sea, Southend. And they decided to convert it as an old people's home in the style. So architects gave instructions for all new joinery to be made, and some £250,000 worth of new joinery. Lovely, isn't it? Turn the page. 2 years later, the whole lot is rotting and there are mushrooms growing everywhere. The reason? The timber specified was tulip wood, canary white wood, which has no durability at all. Perhaps if they'd specified a preservative treatment, it might have got away with it, but no, the wrong timber, the wrong specification. All scrap. Dreadful. Next picture, please. This is even more amazing. This building had timber boarded roof with no felt on it, and at the bottom is the bottom rail there is a heat treated wood, which is quite durable. And the idea was that rainwater coming down the roof would be deflected by the heat treated board and deflected into the metal gutter. The preservative treatment specified 1 coat of Protein 5-star wood preservative as available at your local builder's merchant, with the result that less than 2 years later, next picture, that's what happened. Just crazy. Next picture. Right. Now we're into the realm of preservative treated wood. Now here's a demanding application for preservative treated wood. These are preservative treated logs set in concrete, and they're about 4 foot high. They're holding back the land on the other side. Now, the architect hasn't thought about not only what's the design life they want, but what's the risk of it failing? Well, this is a kindergarten playground here. If one of these logs falls over on a child, that might be the end of that child. And at the end of the design life, what's the cost of replacing it? You're going to have to pull those out, break out 50 tons of concrete, mass concrete, and reset it. Meanwhile, the land here has all fallen into the excavation. You know, this. Anyway, so after 5 years, you see the next picture. All these poles are rotting. Lack of preservative. There's more of a reason to it, but I haven't got time to explain that yet. Next picture. Okay, this is in Sevenoaks. Preservative treated machined round logs. Again, this is holding back a lot of land on the other side. And after a couple of years, next picture, yeah, you can just knock a hammer right through it. Now, the fact is that if you go to preservative treat wood, you'll only really treat the sapwood. And in machining these logs to a perfectly round cylindrical cross section, they've machined off all the sapwood. So there's been no uptake of preservative. Next time you're out looking at a telegraph pole, if you look 5 feet from the ground, it's got letters and numbers carved in it. And the top row says something like IF, that's imported pine. The next row says something like 34L, that's 34 feet light gauge, because that might be 9L, 9-meter light gauge. And then the next row has 2 numbers, which are the year of manufacture. So I set up an Instagram channel saying, let's find the oldest telegraph pole around. And the oldest we'd found was down in Wallingham, 1935. Well, that says something about performance of creosote, doesn't it? 1935. And then somebody trumped that and said, no, up in Orkney, they were widening the road and they had to move a telegraph pole. And it was dated 1892. So they thought, this is so remarkable, it's now in a museum in Orkney. So that's, yeah, but that's only because it's always pine. The pine sapwood is very treatable. So you have a thick band, which you could do a bit of damage to that band, and you've still got a treated band to protect it. If you're treating this, penetration of preservative is so small, it's rather like slipping a condom over the pole, and easily damaged, and things get in. Next slide, please. Yeah, right. You want a quality home? Berkeley Homes, of course. They specified untreated pine painted for balconies. And the next slide will show you what happened after a couple of years. You see the design? The bottom rail is a channel that the balusters slot into, and the little spacer block keeps them spaced apart correctly. Well, that bottom channel is a bucket into which all the water collects, and so the decay accelerates. Yeah. That all had to be scrapped, and the job went to Brooks Brothers in Malden in Essex. Next slide. These are switched on. They're a switched on company. The timber is all dark red Meranti, which is pretty durable anyway. All the horizontal surfaces, you can't see it here, but they all have a slight slope so that the water drains off. All the edges are radiused. There are no sharp arises. If you had a sharp aris, then the paint film thins at that point. And all the fixings are A4 stainless steel. So that's going to be good for heavens knows how long. Nice work. I like to see nice work. Next picture, please. Right. This, you'll love this. This is architectural folly at the extreme. This is a building you could go and see in York Road, King's Cross. And the architect specified these vertical timbers, which architects call a brise solaire, to sort of scatter the sunlight. And she specified 4-inch by 9-inch oak. And they are generally 10 feet long, but the second lot down are 20 feet long with a splice with a fish plate. And she said kiln dried. They duly arrived from a timber company in Birmingham. French oak, kiln dried to 12%. If you know anything about oak, to dry a 4x9 from green to 12% would probably take a couple of years and cost a fortune in fuel. So although you could measure 12%, 15% moisture content on the surface, 6 millimeters down, they were still green. Anyway, next picture. Here's a splice, and it's a gentle breezy day. Just a gentle breeze. And all these fins are flexing like that. So sooner or later, that joining plate is going to fail in metal fatigue, isn't it? And these heavy timbers will fall off the building. That's just the start of the problems. That there are more. As the timber dries out, it tends to split, tends to twist, and the forces are greater than the anchorage points in the building. So we're at the stage of inspecting that 3 times a year to make sure it's still safe. Next picture. Oh, is it the execution? Ah, right. Next picture. This is, say was, a new housing development in Peckham. And it's timber frame construction, but it's a sort of hybrid. Sometimes it's timber frame with timber cladding. Sometimes it's timber frame with brick cladding. And like so many projects, it had stalled, it had run out of money or something, and the whole site shut down for a while. Then they found the money and had to get it finished. Well, I was called because the balconies were rotting. That was the primary cause, and that was easy to diagnose. But when you're writing a report like this, you get to the point where you say, I would be failing in my duty if I did not draw your attention to the fact that, and here are 1 or 2 things that I drew their attention to. Next slide. Well, there's the balcony curbs are rotting away. The arrangement for the balconies, they're timber frame balconies with a plastic membrane, and the rainwater drains down sequentially from balcony to balcony to balcony. The drains tend to get blocked up because all their building debris they've stuck underneath the decking just to hide it. Next picture. Well, the timber frame shrank during the winter, as it's perfectly entitled to do. And normally you leave a clearance between the timber frame and the cladding. Well, they didn't here. So all the boiler flue terminals were bent off the boiler like that. And the gas service pipes were also bent across the screw threads like that. Absolutely lethal. Then you start to, that sets your alarm bells going. So you start to examine more closely and you find there are no fire stops behind the cladding. This is just a mini Grenfell Tower waiting to happen. Next picture. Okay, so I took a soffit off under the balcony. I told you there was a damp-proof membrane, plastic membrane to make the balcony watertight. How did they fix the membrane down? Hundreds of ring shank nails. Just. Of course, the people who did this are long since gone. They've run to the hills. Nobody knows where they are. Next picture. This balcony was secured by 1 bolt and applied a test load to see how much it deflected. So just applied 25 kilo load, which is like you leaning on the balcony looking over at kiddies in the playground below, and that's how much it bent. Just waiting to kill somebody. Next picture. Then I was asked to go to a timber frame development in Southwark, which the design of the building, it looked like a Victorian warehouse, brick clad, very nice. But the balconies were jetted out from the timber frame, and they use a material called paralam. It's like shreds of veneer, which are all compressed together to make beams. It's good material, performs very well, but it's not designed for use outside. They hadn't put any weather protection over it at all. So I stepped out on the balcony 4 floors up, prodded away with my screwdriver, at which point it occurred to me I'm in serious risk of being on the ground with my head through a paving slab. That was really, really a dangerous moment. Ooh. Next picture, please. Yeah, that's paralam. You may have seen this. It's good stuff. It's all made of aspen poplar. Next picture. You don't need, this is a £1 million luxury house. And where's the fall in the sill? So all the new joinery is sitting in a bucket. Just incredible. Next. Or is it the material that's at fault? Well, this was a new hospital, 9,000 square meters of plywood flooring. And that was then covered with sort of a lino fitting, so that mechanized floor cleaners, things you motor along, could motor along, keep it clean. And after a short while, those cleaners were rather like an Alton Towers ride, bucking up and down. Well, clearly the plywood was not up to scratch, so took some away this for examination. And it's supposed to be, the specification is it should stand up to boiling water for 72 hours after a 24-hour soak in cold water. After the 24 hours cold soak, it was all falling apart. And after 1 hour of boiling water, everything had failed. So that required a bit of extra research. The adhesive for that quality of plywood should be phenolic, which is a brown, very dark brown color. This wasn't quite right. So took some of that for analysis. That's actually urea formaldehyde, which is, you may know, as cascamite, but with lots of dye added to it to make it look like it's phenol. And also it had so much chalk filler in it, the extender to make the glue go faster. So I thought, how on earth did that get a CE mark? Get the CE certificate, find that was forged in Holland, and it said, we have visited this factory and it is capable of producing type 4 plywood. Not that it is type 4. What's the value of that? It's very sad and expensive mistake. Next picture, please. And if you've ever seen this, this is it's called a crib wall, and it's interlocking timbers. Timbers go back into the hillside there, and it holds the fill up. So it's a retaining wall, and sometimes they grow vegetation to help make it look pretty. It's generally it's New Zealand radiata pine, which is very treatable, treated with a high loading of preservative, and designed for a 60-year life minimum. Well, this had failed after 10 years. And next slide. Householders were somewhat alarmed that this was overhanging their houses 30 feet high. That's a combination of poor treatment, copper tolerant fungi and everything else. So Barrett's did the right thing. They had to move everybody out, to a lot of demolition to get at it. And the person who lived in the bungalow bounced on top of this wasn't very happy either. Next slide. Yeah, you all know about the importance of moisture content. This is a very high class modern double glazed joinery that uses aluminium works on the outside, because that's got far superior weather resistance, and oak for the rest of the frame, because it looks very pretty on the inside. And after a short while, they found they either couldn't open the windows, or if they did open them, they wouldn't close. And it turned out that this was laminated oak, laminated with a cross-linking PVA adhesive, which is a high-performance product. But in order to do that, you have to dry the timber to below 10%. So they've got their laminated timber, machined it up with great precision, you know, to the nearest 1/10 of a millimeter, and it slowly picked up moisture from the environment, expanded a bit, and won't fit. So they went back to Timnet, the suppliers, and said, what the hell's going on? And Timnet said, oh, but it's your responsibility to make sure that the moisture content is suitable for the final application. And what the joinery company said is unrelatable here. It's totally unreasonable. Yeah. Next picture, please. So what can be done? And the answers are, well, Alex de Rijk, who's on the woodworker program tonight, he was the architect for the Hastings Pier restoration. And if you're near Hastings, have a look, because just for the quality of the workmanship, it is absolutely stunning. If you get at the entrance point, get your head down to deck level and look right there along the deck, and you won't see a screw more than a millimeter out of line. It's absolute perfection. All the boards, they're Eckie boards, radiused edges, the meeting edges are splayed so that stones can't get jammed in the gap. They just drop away through. Visitor center on the middle of the pier, Alex de Rijk designed, beautiful. So it can be done. Next picture. And if you're in London, there's a performance venue called the Roundhouse at Chalk Farm. It was Robert Stephenson's engine shed for the new railways, built in 1836. Yeah. Now, I was asked to go and do structural or condition survey before they started the renovation for turning it into a performance space. It's about year 2000 as well. And I was 60 feet in the air on a cherry picker in the middle of the building. And I turned to my colleague and he turned to me at exactly the same moment. And we said, how did they build this? They couldn't ring up Sparrows and say, look, send me a 30-ton mobile crane tomorrow, will you? It's incredible. Once it was assembled, it holds itself up. And you think, how do they get it there? Well, now, then, after only 10 years from 1836, trains have got too big for it. So it went out of use and it became the wine store for Gilbey's vintners for the next 100 years or more. And then it lay in a sort of semi-dereliction. And now I'd say it's just wonderful. With the new lighting, they cleaned all the timbers, is beautiful. And in the whole structure, we didn't find a single defect, not one, because Stephenson had built in 3 barriers to moisture getting in. Nick the lead off the roof? No problem. We've got tar underneath that. Strip the tar off? No problem. The joists sit in a cast iron shoe embedded in bitumen with water drainage holes all around the outside of the shoe. And now architects are building things where there's only 1 barrier to moisture getting in. No wonder we dash for trouble. Next slide, please. So I think the answers are education, never ending, never too much. More training and proof of ability, you know, NVQ, sitting guilds, etc. Better quality control. There's no point in having standards unless you can prove they've been achieved. Now, where's the quantity surveyor to sign off the payment for the job? Well, probably a brown envelope involved somewhere there, I don't know. Suppliers often get away with supplying poor quality. So I say it should be industry-led rather than policed. That's what will happen. And all the time, research goes on to improve materials and methods and how we use them. But sadly, in my experience, when wood fails, the only winners are often lawyers. And at that point, there is no connection between law and justice. So there you are. I hope that interests you. It certainly keeps me busy and interested. Yeah.
Gervais, that was fantastic. Thank you very much for sparing your time for that. We usually, oh gosh, look at this big reveal. At this point, we normally open up for questions. If you haven't been here before, if you put your name in the chat, just your name, I'll call you in order and you can ask any questions you might have. And this evening, first in is Jim. So good evening, Jim.
Thank you so much, Gervais. That was brilliant. Just everything about it was technically, the breadth and depth of your knowledge, just amazing. I was fascinated on your Burgess saw, bandsaw, and that was the first thing that you mentioned. Was I was intrigued when you said it was the best tool you effectively that you bought. And I totally agree with you. I've got one. Actually, I've got 2, but I bought one at a boot fair for 10 quid. And if you fettle it, but I've never seen the idea of the little spring screw. So I'm going to go out with a drill tomorrow and drill them out and put bolts in for it. But on that, one tip of upgrading it that you may not have, I picked up in passing, was on the 2 guides that guide the belt, the blade. They come usually with a block of steel either side, and they push them together and align it up. The tip I heard was to cut a couple of blocks exactly the same out of lignum vitae and stick them in, and you've got a self-lubricating, absolutely silent bandsaw. And I did that, and it worked. Did you do that?
I use high-density Teflon.
Oh, right.
Which is
so probably the same effect.
Same
probably
effect,
the
yeah.
But the
And,
thing about the lignum was it's self-lubricating, so it lubricates the blade at the same time.
Exactly.
So fascinating, but yeah, absolutely brilliant, brilliant talk.
I also set it up that the inside guide is actually touching the saw, actually
Right.
pushing the saw slightly.
Yep.
And that means the blade can now only move outwards. It can't move inwards.
Exactly.
On my
Well,
other bandsaw, which is a Charnwood, I modified the doors so they bolt up tightly to do the same thing, and it transforms it.
Yeah.
The other thing I use is, because lots in the blade, a former student of mine runs a company called Tough Saws down in Monmouth.
yeah, Ian, and I get my. That was my next tip, but you beat me to it.
The quality of his blades.
Yeah.
He never loses a tooth at the weld.
No.
And I discovered his vari-pitch blades, where no two teeth have the same pitch. If you're cutting up really high density timbers, if you're a guitar maker or something, you get no washboarding at all. And it doesn't make any noise. So there's nothing to excite the blade into resonance. They just hiss as they go through. So I saw to minus nothing plus 0.2.
Yep.
It comes out virtually plain.
His blades transform it. I think that was the other eureka moment for me. And I use exactly the same. He recommends, because he and I have known each other for donkey's years, and he recommended the skip blades and the variable pitch blades. But I've actually cut 1 inch thick bronze with his blades on that saw, 1 inch thick and no deviation.
Wow.
And a friend of mine in Italy asked for a lever cap, and he sent me this block of bronze, and I had to cut the curves in it, and it cut the curves to the line.
Wow. Well,
1 inch thick bronze. So it's people say, oh, it's a rubbish saw. Absolutely not. It's how you use it.
And I tried to do the same with my brother's Black & Decker, but that just has a plastic cover door. And
all right.
There's no stiffness there. So there I welded up a square steel tube behind it, to hold the end, because the upper guide mustn't move backwards or forwards at all. It's got to be absolutely rigid. Yeah.
But it's, every single person on this Zoom call is now going to be whizzing over to eBay, and you won't be able to buy a Burgess bandsaw for love nor money. But yeah, absolutely, it's a hidden secret, and I'm glad somebody else is as crazy as me.
Excellent.
Thank you so much. I won't take up any more of your time, but if you have any more tips on that, drop me a line.
At the other extreme, I've got the worst saw ever made, which is by Proxon.
Oh yeah, I've got that. I've upgraded it with a DC variable speed drive,
right.
Half horsepower motor on the back, and that made it a little bit better, but still rubbish.
No, for doing some of these smallest ones, I've got the one that's 2.5 inch blades.
Yeah, and
it's underpowered, and the motor hasn't got any dust protection. So after 2 or 3 hours work, the motor slows down and seizes up, and you strip the whole thing down. No.
Get yourself one of those motors from, because I see you're into electronics and everything else. Well, get yourself one of those variable speed DC motors, brushless DC motor from a pedal scooter, and and just bung it on the back. It's got the same fitting and everything. I think it's for those electric bikes and things like that, yeah. And it transforms it, and you get variable speed out of it.
Excellent. Thank you.
Thanks, Jim. I think we got Scott next.
Hey, Gervais. Thank you for that. That was an amazing talk. I thoroughly enjoyed absolutely everything you were talking about there. It gets right up my alley. I'm a joiner to trade, a carpenter to trade, and I teach in a college now. So I love it all, especially wrought and everything else. What I was going to ask you about was, what's your thoughts on stabilized timber with like acetone, like a Koya?
A Koya, brilliant. Yeah.
It's not that I'm concerned so far, and I think that's the key word is so far, is all the testing they've done on it, and it's only gone back a certain distance so far because of when it was developed. I'm not saying it's limited, but I mean, they're given 25-year life, 25-year plus in the ground and 50 plus external.
The talk I was giving this morning showed an application of Accoya in Holland. It's called the Moses Bridge. If you search for the Moses Bridge,
I've seen it. I've not been there.
It's a bridge which is effectively a trough going across.
Yeah.
Yeah, great.
It looks like
It's not without its problems, because the vast majority of timbers aren't permeable. So they have to use radiata pine from New Zealand, and there mustn't be any heartwood in it. So it's they have big quality control problems. The other product is Kebony, where this is difficult to pronounce, furfurulated. It's like trying to pronounce meteorology, you know. That's very dark in colour.
And I know they're actually producing both like sheet material, man-made sheet materials now, like tricoya and stuff like that.
Yeah.
Like MDF product, obviously, it's got the similar qualities. It's quite interesting.
At a price.
Yeah, I same with Accoya. It's not cheap. I've not tried to buy any. I do research it and I try and look up on it so that I know about it. I've got a couple of bits in college, but I've not used it very much for actually working.
There was another third product called Lignia, where it was impregnated with a phenolic resin, which stabilized it remarkably. And sadly, they went out of business in July for a number of reasons, but Accoya bought them up in order to take them off the market.
Yep.
Sad.
It's interesting because it is expensive. I just wonder if the cost will come down, making it more, because as far as I'm concerned, I don't think you won't either.
No.
As far as like for external windows and doors and cladding, I'm not saying there isn't a better product. Hardwoods have got a similar lifespan, but I think it's a little bit cheaper than some hardwoods maybe. And we're not moving it as far. It's coming from, well, if it's coming from New Zealand and then to Holland.
They do alder that's been treated by the same process.
Yep.
They import American alder, and because we have a lot of alder in Britain. I mean, I'm surrounded by, well, I own a bit of woodland. It's family owns a bit of woodland down near Leith Hill in Sussex, in Surrey, and part of the wood is overcoppice alder. Now they're 40 feet to the first branch and 16 inches at breast height. They're big trees, and well, I can't get them out. Otherwise, I'd set up a sort of competition for let's design and build something out of alder. But I went to Accoya and said, we got all this alder in Britain. Why don't you use British alder? They said, sure, yeah. Can you guarantee us 2,500 cubic meters a year? And that's where you come unstuck, because there's no infrastructure for that.
Yeah.
And a lot of the woodland owners are saying, why should I sell you any trees? I make more money out of selling shooting rights or paintballing or something like that. No answer to it.
Brilliant talk. I enjoyed that. Thank you very much.
Good, pleasure. Good.
Thanks, Scott. And we've got Matthias next.
Yes, again, thank you very much. Absolutely fascinating from start to end. One comment and one question. So the comment, I live in Belgium, and in Brussels, particularly in traditional working class areas in Brussels, one of the worst insults you can hurl at someone is to call them schieven architect. It translates literally as wonky architect, but means bloody architect. And it dates back to when they constructed the main court building on top of, looking down on the poor neighborhoods of Brussels back in the late 1800s. But anyway, so yeah, so to call someone a bloody architect is a deadly insult. I wanted to follow up, as it were, on what Scott was asking. What's your take on torrefied woods?
Yeah, it's interesting. Torrefied or retified? Because
I was thinking torrefied, so where basically they an extreme heat treatment that is supposed to stabilize it and make it much less vulnerable to movements.
Yes, the French call it retified.
Oh, right.
And it came about because somebody observed that if you charge your fence posts in a fire, then they didn't rot away so quickly. So we are just, I'm guilty as anybody, we assumed that the charcoal layer was a barrier to insects going in. But the French identified that the high temperature actually chemically modified the wood.
Right.
So these processes, both torrefied, retified, thermo wood, Plato wood, Dutch one, they're heated in a low oxygen atmosphere, about 180. There's a certain loss of strength and there's brittleness as well, but a great increase in stability and durability. Yeah. Usually I come across the word torrefied. You know, we burn a lot of wood pellets in this country.
Yep.
As we speak, Drax Power Station has burnt 500 tons of the stuff.
Yep.
It's incredible. They have to torrefy the pellets before they're shipped.
Oh,
Otherwise, they can sort of ferment in transit with a dangerous buildup of gases in the hold of the ship.
bloody hell.
So the torrefaction process makes the pellets very brittle.
Yeah.
So they're ground up into, it's a dust as fine as talcum powder, and then it's just blown in as if it's a gas.
Yes.
Yeah.
Lord love me.
Yeah. Interesting stuff. A lot of research and development still going on in that area.
Yeah.
Yeah.
You know, I have a pair of winding sticks that were made out of torrefied maple, and supposedly they're supposed to be very, very stable, keeping their shape and so on. I haven't really verified them for that, but I can understand what you say about brittle, because there is a brittle feel to the wood.
Yeah.
And they smelt like an overheated sauna for about 2 years.
Yeah. Old bonfire, anyway. A lot of them, I think.
Yeah, exactly.
Yeah.
I mean, thank you very, very much. This was absolutely fascinating.
There's conferences every year on wood modification. All sorts of ideas coming up on that one.
Yeah.
Thanks, Matthias. And next, we've got Shrenick.
Got a spotlight myself, have I?
Yeah, well, I'm trying to do it, but as you know, okay. I'm new to this.
Here we go, I've done it. All right, thank you for a brilliant talk there, Gervais. I'm going to be cheeky and ask you 2 questions. So I'll start firstly with, we're talking about different types of materials, especially sheet materials. I think Scott mentioned a sheet material which is related to Accoya or something. Yeah, so
another one you mean, yeah.
What I wanted to ask you was, have you heard about hemp board?
Yes, indeed, yes.
And it's not available in the UK as far as I can see, but it's growing in the US, and hemp in the construction industry is sort of growing the use of it, and they're claiming that it is more eco-friendly.
Well, you know how people say wood doesn't grow on trees, you know, and my answer is, well, it's true, it doesn't. There are other wood sources. So
yeah,
there are all sorts of other lignocellulose materials which we can use. So from the Low Countries, where they grow flax, got the residues from flax called bagasse, and that makes a particle board, which is very good for middle of solid doors. Other countries use rice husks or whole range of materials. So hemp residues, certainly.
Yeah.
And it's quite strong material too.
And my second question was actually around glulam beams, because you focused on that a few times during your presentation, and I did a structural appraisal of the Warner stand at Lord's Cricket Ground. I don't know if you've seen it.
Yeah.
Quite a different design in terms of using glulam beams for the canopy on the roof. But they span about 24-25 meters, some of them.
That's quite
between 18 and 24 meters they span, and they're not actually glue laminated timber the full length of it. A lot of the glue lam construction is actually with a steel frame inside, and the benefit of glue lamination is you can clad steel and still make it work.
Yeah.
Do you think that we might actually find a way to make timbers strong enough, so impregnating them with a resin or something that makes them strong enough to actually span those distances as glue lam beams?
I don't think you need to. So again, the vast majority of timbers are highly resistant to impregnation with preservatives. It's a worry to the wood protection industry that these CLT tower blocks, they seem to be forever building higher and bigger, but there's no preservative treatment. And we say, well, what would happen if there was a slow water leak behind the bath? You know, a little drip, drip. It would be absorbed by the timber. You'd never see it until 3 years later, there are bracket fungi growing out of the wall. And then how do you repair it? And we were so concerned, we convened a meeting. This is the Wood Protection Association. Convened a meeting with KLH, who are the main Austrian manufacturers, and NHBC, you know, house insurance.
Yeah.
Who are very concerned about this. I mean, a building's supposed to be designed for a 60-year minimum life. And the man from KLH said, oh, we're not selling a building system, we're selling a component like a brick. And there was a stony silence for a minute. And the man from NHB said, did you run that past me again? Incredible. So that's where we are. But there have been a few failures, and it may well, you know.
Yeah, I'm actually a project manager within the construction industry, and I'm currently working in rail, but I've worked in other areas over some of my limited experience. I'm still quite young, and I could quite relate to some of the scenarios that you mentioned earlier about design, and
Yeah.
I thought that was quite interesting.
But with glulam, I've learnt that the only limitation is the engineer's imagination.
Yeah.
I went over had a Norwegian girlfriend one time, and I went over to see her in Lillehammer, and they had the Winter Olympics there in 1994, I think it was. And one of the ice rinks has a roof that looks like a Viking boat upside down. Well, I knew it was big until you went in, and you just saw it's 94 meters clear span, almost with clouds on the top, which is remarkable enough. But then the architects got to think, well, it might be 3 meters of snow weight on the roof as well. Yeah. If you land at Oslo Airport, it's glue laminated beams, which are 140 meters long. 100. Yeah.
Now I've got to fly to Oslo to see this.
140 meters. Japan holds the record, I think, which is 150 meters dome with 150 meters span.
Wow.
Yeah. And then some of them are just beautiful because of their complicated curves and shapes. There's one in Germany, which is very famous, and it took them 3 years to design and only 3 months to build. It's so complicated, yeah.
Yeah, there's a few Dutch pieces of architecture as well, which are quite impressive as well.
If anybody's interested, I've been running it for years now. Woody people around the world. I've said, send me your 7 wonders of the wooden world, and quickly we decided there've got to be 7 categories. You know, there's the natural world, old buildings, new buildings, works of art, musical, marine, and aircraft, I think it is. And we keep adding to this, and just incredible. That's incredible.
Well, thank you very much, Gervais. I'm going to let Mitch move on to the next speaker.
Okay, make sure you know how to get hold of me. It's
Next question.
if you search my name, it should come up second hit, I think, which is not my doing. It's the publishers of the journal. And happy to help you in any way.
Thank you very much. Mitch, you're muted.
Just a rookie mistake there. Next, we've got Anton.
Also, just want to thank you for a great talk, and a lot of what I was trying to ask or talking about was already mentioned by Schrenik in the last question. But I just wanted to thank you for setting a focus not only on wood treatment but also on constructive wood protection, which seemed to be in the latter part of your talk quite focused, and this I really like a lot, because I think loads of woods can be used untreated or almost untreated if they are constructed well. So we are building quite huge buildings out of wood in Austria, lately, especially with glued beams, like you were talking about, and it works just well with relatively ecological friendly treatments. It's just a matter of construction. So
yeah. Then also in go back to Norway, to Lillehammer, there was a dentist there, and he decided to start collecting old Norwegian buildings. And they're in a sort of living museum, and it's truly a living museum because they allow students to live in them. And the deal is, if you're a visitor, they've got to step outside whilst you inspect it. Anyway, they said to me, they showed me a building there which was nearly 1,000 years old, still in perfect condition. And they said a wooden building needs a good hat and a good pair of boots. So exactly. Nice eaves overhang, and the sole plate is well off the ground, you know. And then I examined that sole plate, and the wall timbers sit in a groove, and the groove has drainage holes.
Yep.
Lovely, you know. And the roof has wooden tiles, you know, shingles we call them, but underneath that it's got birch bark tiles, which are, you know, half cylinders, which overlock, so it's vapor permeable but very watertight. I love it. Yeah.
I mean, where I grew up, we have you know, hay buildings which are 700-800 years old. Most of them are large, which is easy to use, but there are also spruce ones surviving for 500-600 years, untreated. So just thank you, and then Schrenik said a lot for what I was.
Tell me, what's the picture behind you?
Oh, that's a presidential room of our president. We had our national holiday 2 days ago. So that's Maria Theresia.
Oh, right.
Marie Therese, Empress in the 18th.
Right, yeah.
So thanks for a great talk. Well, was really insightful and really exciting.
Good, pleasure.
Thank you.
Thanks very much, Anton. Now we've got Eric.
Good heavens.
Hi, Gervais. That was a fascinating talk. I'm incredibly interested in all this. I'm not at all trained in woodworking or anything, and at the moment I'm building an oak frame workshop from a sort of basic kit, but the rest of it I'm making it up as I go along, and I might not be making it up in the best possible way. I'm making doors at the moment with an oak frame around them, and I was wanting to use the weiny edge and do something sort of nice and artistic, and I was strongly advised not to use the sapwood to cut that off. So I've done that, but you seem to be saying that if you wanted to treat it, that it was better to have the sapwood. So should I have left the sapwood on and treated it?
This is oak, is it?
Oak, yes. Yeah.
It wouldn't be treatable. And it's very susceptible to lictus beetle.
Right.
Which is very destructive. So the sapwood must be taken off.
Right. Well, I've done the right thing then. That's good.
Oak is totally untreatable, but it's also very, very durable. Although I must qualify that, I had a case a few years ago. Somebody bought oak railway sleepers, but they were new ones for landscaping their garden. Now, you know, railway sleepers, 5 inches by 10 inches, should have had a life of 80 or 100 years. I mean, it lasted 3 years.
Oh.
And it turned out it was from Germany, and it was red oak, Quercus rubra, which has no durability at all. But the importers had just dropped that word red. Sneaky, you know. But red oak is great fun. You know, if you look at my videos for school children, you can take a 2-inch square piece of red oak, this long, dip the end in some soapy solution, and you can blow bubbles through it. It's completely permeable. And so children love doing that. I send them away with a little piece of red oak and a film canister full of bubble blowing solution.
Not good for building with.
Well, you don't make barrels out of it.
I
mean, leaky barrels, yeah.
But no, that's great.
Are you framing? This is green oak framing, is it?
Yes, yeah.
then you have to be careful how you design it. I went to a house where the green oak frame had been bolted together, and of course it takes years to dry out and shrink, and the joints all start to open up. So it should be with draw pins that hold it pulled together.
Yeah, no, no, it is. Yeah, I mean, I've got some interesting shakes developing, and I think that's going to be going on for a while.
That's yeah. If you can avoid direct sunlight, that'll help.
That's harder. It's south facing.
If you took a round pole and dry it out, as the outside shrinks around the core, then splits will open up. So the solution they do in America is to run a saw slot along one side, and then as it shrinks, that saw slot opens up like that. But no more splits open up anywhere else, just at that.
Right.
And that's easily done with a skill saw. You can just run it down the length, somewhere discreet. Yeah.
All right. No, I certainly didn't know that. So it's probably a bit late for that now, but that would have been useful.
How do you feel about this? There's a man locally who collects classic cars. He's got a fleet of Morgans and things.
Oh yes,
So
ash frames.
he had a green oak building erected for it. 3 years later, there's woodworm dust all over his cars. So his action was to ring up Rent-A-Kill, and they came in and they treated it for £2,500. He then went to the people who made the building and said, I want my £2,500 back, please. How do you feel about that?
Right. No, that's interesting. And
of course, the court threw it out. They said, well, you should have asked the builders first. Give them the opportunity to put it right. And so he lost his money. So.
But no, I thought you were going to say something about the the wooden chassis and the cars and the organs.
Right, yeah.
So I always think that's interesting that they've got the strength, and they've done, and if you look after it, it'll last as long as the car.
Unlike Morris Minor Travellers.
Yes, the half timbered car.
Dry rot, everything.
But no, that was great. That was very, very interesting, and thanks very much for your time. Don't be a stranger. Feel free to come along and join us next time as well.
Thanks very much, Eric.
Right, thank you.
Okay. Next we've got Richard. I think Richard's the last one. So if anyone else wants to ask a question, get your name in quickly.
Yeah, good evening, and thank you for your talk. When you were talking about the Roundhouse, it reminded me of another Victorian wooden building that I'd seen at Chatham Dockyard. It's a very large, enormous wood frame structure which covers one of the docks.
The drying shed.
Yeah,
I surveyed that. Yeah.
You've surveyed it, have you? Yeah. So my question was, well, did you know it, and B, have you got anything to say about the state of preservation and the features of construction and water barriers and so on?
That's in pretty good order and condition. Very impressive.
Yeah, I've got a picture of it on my screen at the moment. I don't know if Shrenik, is it possible for me to show my screen somehow?
Yeah, there's a green button. Yes, it is.
Yeah, what do I do?
You click share screen at the bottom of your screen.
Little green up arrow at the bottom in the middle.
Oh yeah, share screen, yeah.
You select the window that you want to share, and then you click done.
Okay, and share. Yeah, there it is. Can we see that?
No.
It's loading.
Oh, loading. Oh, yes. Yeah. Magnificent, isn't it?
Yeah, it's astonishing, and what you can see there is only part of it. That's like a deck that's sort of, you're looking at underneath that deck is a space which is at least as big again below it.
Oh, you know, years gone by, they built huge wooden structures.
Yeah, so I was just astonished to see it, and I'm surprised that it had lasted so long.
Yeah, yeah. That's an interesting part of the world.
Yeah.
Thanks very much, Richard.
Okay, thank you.
And we'll quickly get Rusty in before we close.
Richard, you can stop sharing the screen. There you go.
Yeah.
Hey, Gervais, thanks for the talk.
Hi there.
As I was listening to the talk, maybe it's because I'm wearing this T-shirt today. I don't know if you can see it, but it says Decatur Orthodontics. This is where I take my daughter to get her braces, and her orthodontist's name is Dr. Oral something. And at the same time, I'm transitioning to chair making from being a university professor, and my last name is Chernas. And I was wondering, did you get into the wood because of your last name? Because plastic surgery probably wouldn't have gone well.
That's called nominative. That's called nominative determinism.
So you feel like it was all predetermined?
Maybe. My previous boss was Pittman.
Uh-huh.
And when he got a bit difficult, I said, just remember your place, Pittman. Sawyer's on the top, Pittman's underneath, you know. And the definitive book on circular saws was written by Stevenson and Plank. And bandsaw services in Windsor run by Mr. Cutting.
Well, I'll add to it one more, that there's a very important transformation in statistics done by Box and Cox. And the story has it that they decided to work together because they thought it would be really funny to make people say their names in turn. Box, Cox, transformation. Anyway, thanks so much. Appreciate your time and information.
Thanks very much, Rusty. And thank you, Gervais, so much for staying on and answering those questions for us. And as has been mentioned before, please be along to future editions of Bench Talk with us, and we'd love to see you.
Love to.
Right, so it is traditional now to raise a glass to our talker.
Oh, well, I'll raise my glass to all you then.
So, cheers, Gervais. And
Cheers,
the bench.
Gervais to the bench.
Gervais to the bench. Cheers.
Cheers, Gervais.
Yeah, cheers.